Hey guys, welcome back. In this video, we're going to learn how to integrate using U substitution that leads us to a natural log as our final answer. So once again, we use U substitution when the degrees differ by 1. So that's a 1, that's a 2. So the difference is 1. What you want to do is you want the person with the bigger exponent to be your U, but you want the entire expression to be U. So you say U equals x squared plus 1. Then you take the derivative of that, and that's going to be du dx equals 2x. You basically cross multiply, divide, and now you have du over 2x equals dx. You go back in order. That's integral sign. We never touched the x. We made the denominator, all of it u, and now we have to change the variable dx into du over 2x. What we notice here is that the x and the x cancel out and you're left with 1/2. So you have 1/2 1 over u du. So all you have to do now is just say which, transcendental function, or what gives us 1 over u. So that's going to be natural log of u plus c. So it's going to be 1/2 natural log, our u was x squared plus 1, plus c. Okay? So that's how we do that one. Now stay tuned for the last one. There's 2 more examples. The last one is the most important one. In this case here, we have the same exact thing. This is going to be a u substitution because we could never ever integrate a quotient. So you need something to be u. So I'm going to make the bottom u, and then I'm going to take the derivative of the bottom. So that's du dx equals 3x squared plus 6x plus 9. So then you're going to cross multiply and then divide. So you get du over 3x squared plus 6x plus 9 equals dx. Once that happens, what you're going to notice is that x squared plus 2x plus 3 over u over du over, I'm going to factor out the bottom so I can have the numerator. Okay, you cannot integrate x's and u's. So that cancels out with this, and you're left with 1/3 1 over u du. Sorry about the neighbors crying. They're always crying when they hear calculus. And it's going to be 1/3 ln of u plus c. All you have to do is put the u back into this part right here. And then you're done with that. So I hope that makes sense. We have one more problem. And what we notice in this problem, which is very important, is that the exponents match. So if the exponents match or the numerator is actually higher than the denominator, then our step is to do long division. So we're going to do long division here. And the way that we do long division is you estimate how many times does x squared go into x squared? 1. Then you do 1 times x squared plus 1 is x squared plus 1. I don't need that there. You're going to subtract, because that's what you do. And then bring down the x. How many times does x squared go into x? No times. So therefore, you're left with plus x over x squared plus 1. So you need to use long division here. All you did was create this to be this. So once you do that, you end up integrating. So we know by one of the integral properties that we can separate these. So the integral of 1 dx is x. This here now differs by 1, where the denominator is 1 higher. So you have to do a u sub here. Okay, so that's that. And then you're going to do du over 2x equals dx. And then you're just going to substitute that. And you're going to say x over, this was your u, du over 2x. These cancel out. You're left with 1/2 1 over u du. That's going to be 1/2 ln of u. Remember that u is x squared plus 1. So your final answer is x plus 1/2 ln of x squared plus 1 plus c. So that's how we do the u substitutions. Basically, the denominator has to differ by 1 from the numerator. The denominator has to be 1 bigger. And if not, you have to use long division. So I hope this video helped. Come back for another video.